Hello, and this is why are moles a chemist's best friend? And yes, those are the beautiful, lovely moles that most people think about. This is a chemist mole in tie-dye lab coat. Well, a mole is how a chemist counts. And we can thank this gentleman, Count Amadeo Avogadro. His full name, he has like 6 names like I do, is on your handout. And this is the number, 6.02 times 10 to the 23. It is a number you are going to become very familiar with. And in all honesty, when I came back to teach chemistry, this was really the only thing I remembered about chemistry. I mean, it all comes back as you start teaching and stuff, but you're all going to remember this number. So in 20 years, when you have children and they're studying chemistry, or 30 years or 40 years, oh, you'll go, oh, Avogadro's number. Yes, let's talk about moles. And everybody pronounces his name avocado, and Trader Joe's actually does have Avogadro's guacamole. Right, there's so much play on word, and you'll have an extra credit chance in there too. For those of you who like lots of sig figs, there you go. They don't actually know the number more than that. There is, you can Google why. So they can only go so many place values with the number, and it has to do with the magnitude of this number. And that's what we're going to talk about in a moment. The next slide actually is me. And I'm going to talk about what a mole is.
Hello, it's me. Of course it's me. And we're here to talk about a mole, which is my best friend, and I keep dropping him. So here's the Sherpa mole somebody made for me. It never loses its glasses like me, and has its little knock on. Notice that? So what is a mole? And why are chemists obsessed with it? Well, it has to do with this gentleman, Amadeo Avogadro, who is a count, which just meant he had a lot of money to count. And so let's walk through the example I have on the page. There is a periodic table. If you don't have it, stop the video. And on the periodic table, well, we've talked about those numbers up above the elements, like carbon's number 6. But what about that number underneath, 12.01 or 12.011? This is it. This one, we finally get to see what that number is. So if we look at aluminum, the number underneath aluminum is 26.98. Now, different periodic tables will round it different, have more sig figs, but I'm going to go with 4 sig figs for right now. We could do the 3, 27.0. And what it is if you had 26.98 grams of aluminum, like I have right here, if you have that many grams of aluminum, it turns out in this sample of aluminum, you have 6.02. If you want 3 sig figs, you have 6.02. If you want 4 sig figs, 6.022. Yeah, I'm like triple dipping here, so this video is going to have to work for like 3 different classes. So some of my classes, we're going to do it with 3 sig figs, some of us will do it with 4. So go with whatever I tell you. Times 10 to the 23 atoms. That's a crazy huge number, right? If we tried to write, this is why we use scientific notation. We would have 6022. And then we'd have to keep adding zeros. Until we got not 23 zeros, we would need I think I need 20 zeros. Yeah, that's how big that number is. Can you even see all the way to the end of the board? Who could write that number out like that? How did he figure this out? He actually didn't come up with this number. He came up with the inverse of this number, Avogadro, and everybody laughed at him, and nobody believed him. And I talked about it in that other video. Albert Einstein was the one who brought it back. But Avogadro gave the name molecule to things, like water, when you have a chemical compound. And So the word mole has to do with that. So this is 1 mole. So if somebody sends you to the store to get eggs, they don't say, hey, go get 12 eggs. They say, get a dozen eggs. And so that's what's going on here, is we just say, instead of, I want 6.022 times 10 to the 23 atoms of aluminum. Aluminum's not compounds, we call it atoms. You say, I would like 1 mole of aluminum, please. And I would say, here you go, here's 1 mole of aluminum. If we did that with gold, I don't have my sample of gold, the student took it. We'd look up gold on the periodic table and we'd have 197.0 grams. If you had 197.0 grams of gold, you'd have a lot of money because gold's worth a lot. You would have 6.022 times 10 to the 23 atoms of gold. I don't have gold. I have fire and brimstone here. We find sulfur on the periodic table. It's 32.07, and I found a sample of sulfur that was 32.07. We can do the same with silicon. Somebody gave me these wafers that were rejects, and it turned out this wafer weighed 28.09. My cheat sheet's the periodic table. It's going to be yours too. And look, you can look at yourself in there, and we can look at myself. We have an infinity mirror, and keep looking and looking and looking. If you have copper, copper's a fun one. And I'll try this one at home. If you have 24 copper pennies, you have a mole of copper. The problem is, in 1984, they realized copper was worth more than a penny. And so now pennies are zinc, and they just have a copper coating. So you have to get pre-1984 pennies, which I do have here. I have 24 of them. And so I have whatever copper's mass is. Copper is Cu, so 63.55 grams. So let's do it for a chemical compound. So water is H2O. So we have to add up the mass of the 2 hydrogens and the mass of the oxygen, and we will get oxygen is 16.0 and the hydrogen's 1.0, so we get 18.0. Some students will do it more sig figs, 18.016. But if you have 18.0 grams of water, you have 6.022 times 10 to the 23 molecules of water. Not moles. Well, you have 1 mole. You have that many molecules. Now, water is a compound. It is made up of only nonmetals. So when they're made up of only nonmetals, we call it a molecule. So those of you in my Chem 104 class, we're going to talk about the difference between different types of compounds after we learn about moles, after the first midterm. For those of you in my Chem 221 and 151, this next statement will make more sense. Aluminum sulfate, based on the charges, is this compound. What we're going to do is figure out the mass of it from the periodic table. So if we look at this, we have 2 aluminums, and each aluminum on the periodic table is, I'm going to round to 3 sig figs, but again, you can use 4, 27.0 grams per mole. We won't put units. And then I have, because of the parentheses, you multiply. These are subscripts. This just means I have 2 aluminums. Everything in the parentheses gets tripled. So when we do chemical nomenclature, we will see why it's written that way. 3 sulfurs, and sulfur is 32.1 or 32.07 grams per mole. And we're going to add these 3 elements together. There are 12 oxygens because it's 3 times 4. So 12 oxygens. And when I write oxygen, you're going to see me put an X. Because otherwise you're like, I have 120. You don't. So the little X is just my way of communicating to you, that's not a 0. That's oxygen. You don't want to write it after because that would mean a symbol, and it's not. All right, and oxygen is 16.0 grams per mole. And you put that in your calculator, you multiply it all together, add it,
And you should get 342.3 grams per mole. Now again, if you're in my Chem 104 class and you want to go with the 3 sig fig rule, you can say I have 342 grams per mole. That's what the numbers, the significance of them are. If we want to write it out like I did with the other ones, we would say we have 342.3 grams. And in that, we would have 6.022 or 6.02 if you're doing the 3 sig figs times 10 to the 23. Now, aluminum sulfate is made up of cations and anions, so it's not a molecule. It's not an atom because it's multiple types of elements. And so we put the word formula units with this. Now, how important is that you are perfect at not calling this a molecule? You would lose 10,000 points in my class if you called that a molecule. That would be awful. We try to respect it, but don't lose sleep over it. I don't like the term formula units. It's tedious. So a lot of people abbreviate it. I'm not going to do that either. You can figure out what that would be. All right, so you would just take how many you have of each element times its number from the periodic table. And you can see where we're going to go with this. We're going to be doing factor label. This is why we did all that factor label, because we have a ratio. We have 27.0 grams per 1 mole. So we're going to be able to do math. All right, we need one more. And this is glucose, blood sugar. So if you have 6 carbons and taking your handy dandy periodic table, you can go with 4 sig figs. I'm going to do 3 this time. 12.0 grams per mole. You have 12 hydrogens, so 1.008 or 1.01 grams per mole. I'm actually perfectly fine with you saying 1.0. So going to 1 decimal place. And then 16 oxygens times 16.0 grams per mole. So this part gets a little tedious because since you're not with me and I can't control the periodic table you're using, the periodic table I always gave out was superior because you had to learn your elements, and the students actually did better when they learned their elements, and it limited our sig figs. My recommendation is you just do either the 3 or 4 sig fig rule, or that you just always go to 1 decimal place. Just be consistent. Some of your periodic tables will have like 6 or 7 sig figs, and you'll be punching in numbers and it'll end up not so good. So we add these together, and for glucose, we will end up with 180-ish. If you do 180.12, if you want to have all those digits. But again, I'm happy with 3 or 4, depending on which class. And we would say that is roughly equal to 6.022 times 10 to the 23. And this is actually a molecule. And so you're going, oh my gosh, how do I know if it's a molecule, an atom, or a formula unit? Well, atoms, it's on the periodic table. I will tell you in the question, the easier way to go through it, instead of saying formula mass and atomic mass, we call it the molar mass. The mass in one of Avogadro's moles. So that number, the 6.022, is a constant. It's called Avogadro's constant. The symbol is a capital N and then a lowercase capital A for Avogadro. A lowercase n means mole. And a mole and a molecule are not the same thing. Like 1 egg and a dozen egg are not the same thing. All right. So, I'm sure there's more. Enjoy moles. Moles are awesome. Be friendly to your moles. Bye-bye. Bye. Bye-bye. Okay, I am aware that I wrote 16 oxygens on there. I don't know why I wrote that. I hope none of you ever have to teach like this, but it should have been 6 oxygens when I did the glucose, and the 180 is the correct number. I'm pondering why I wrote 16. I know glucose. I do this example for 25 years. Hello. Oops.
It's me. Of course it's me.
Next, yeah, let's not watch me again. So there's the number. This is one book or one website writing it all the way out. Again, once you get to about 8 or 9 sig figs, so around the 141, after that, they're not actually sure. There's different ways to figure it out, and you get slightly different, but it doesn't matter. What this is about is how big that number is. So if you tried to count out loud 1, 2, 3, 4, 5, 6, 7, and you said a number every second, how long would it take you to get to that number? 10 minutes? 10 hours? 10 years? Like you never stop. Like in your sleep, you keep counting. Yeah, that's how long. So that's 1,000, a million, a billion, a trillion. So that's a quadrillion. Almost 2 quadrillion years. Yeah, it's a really long lifetime. Start counting. Keep counting. Well, computers can count faster. So if a computer counted, it would only take about 4.2 million years. That's all. Starting from 1 and it counted all the way up to that number. This number is outrageously huge. Apparently, that's the length of time that civilization has been known. I don't know anything about that. A mole, or it's longer in our civilization. So if we had a mole of mini marshmallows, marshmallows are about 1 centimeter in size, and if we piled them up, how deep would it be? Would it cover the state of Oregon, the United States, the planet Earth? Oh yeah, the marshmallows cover every square centimeter of our planet. 10 miles deep. You imagine waking up, you have to dig out of those marshmallows. It gets a little messy around the volcanoes. Yeah, it gets definitely messy. And yeah, we'd all turn into this guy. And there we go. You can have lots of s'mores. That's all we do. All right, what if we had a human chain? So a lot of these came from, the marshmallow one was mine. You guys are going to get a bonus chance to come up with your own analogy or a joke, if you prefer, when we get to Mole Day. You got to wait till Mole Day, which is this month in October. And human chain. I love this picture because I'm pretty sure it's from Nepal. Actually, I don't know, the flag in the center is probably not Nepal, but they dress like that when I was in Nepal and got to teach for a week. So would the human chain reach to the moon? They'd have masks on, don't worry. To the sun? It'd be pretty bad. Oh, it reaches to the sun and back, a human chain. Wouldn't that be wonderful again? We can all hold hands. 2020, as I tape this, pondering, holding hands again. Our human chain reaches to the sun and back 6 trillion times. You just hope you're not the person who's by the sun each time, right? It'd be really warm. I had a student who said, well, if you had a mole of bunnies, how much does a mole of bunnies weigh? She's basically trying to find something that she would get the mass of the Earth. So if we had a mole of bunnies, you get the mass of the Earth. And then I had a student who said, well, there's different types of bunnies. And you got the idea. Don't go there. All right. Well, there's only carbon, an atom. You can pick any atom really you want, but if we picked a carbon atom, and the size of a carbon atom is 140 picometers across the diameter. Remember pico? This font doesn't allow me to do lowercase, but the P and M should be lowercase. Picometers are 10 to the negative 12th. The width of your hair is 10 to the negative 6 meters. So this is 1,000,000 times smaller. That's the size of an atom. So if you line them up in a row, yeah, you're thinking they're not going to go that far. Oh, they do. They go 84 billion kilometers, which turns out to be that many football fields. This slide was there because my dad grew up in Pittsburgh. I think I mentioned this before. I'm a Steelers fan. That drives some students crazy here. But remember the gummy bear? That's the nucleus, and he's a lot smaller than that. So the football stadium was our atom, and a regular little gummy bear would be the size of the nucleus. That's where all the mass is concentrated. So the picture over on the left is way out of proportion. That's what we always call the Bohr model. That's the best we can do trying to diagram, because the nucleus is pretty much infinitesimally small. And that's where matter is concentrated. You should really be thinking, this should be blowing your mind, right? And everybody's always like, oh, let's go, gummy bears back. In case you don't know how far 1.817 trillion football fields would be, the distance to the moon. Right now, the moon is in the apogee. It is pretty much as far as it gets from our planet. I think there was a bonus before the class started about that. Anyway, the moons, the full moons on the 1st and then on Halloween, the 31st of October, they're called micro full moons because the moon is as far as it can be. You guys have all seen the super full moons, or you hear about them. That's when the moon is in its perigee, or perigee, sorry, I'm not an astronomer, I'm an astrologer. Anyway, yeah, this is 84 billion kilometers, and the distance the moon is right now from us is not even 1 million. These are carbon atoms. Kind of crazy how big this number is. Let's say, right, again, it's October, you have a mole of pumpkin seeds, circles the earth 150 trillion times. 150 trillion. That's 12 zeros after 150. Pick pumpkin seeds because it's pumpkin season. They're loaded with fiber, with nutrients, with MUFAs, monounsaturated fatty acids, with protein and lots of tryptophan, which helps us to sleep. And at night, it converts to melatonin. You have to be in complete darkness. You can't look at a computer screen after 10 o'clock at night, or this doesn't happen. Melatonin is actually the best antioxidant in our body. And so at night when you're sleeping, the melatonin is cleansing your body and repairing it. And that's why in the morning you always look better. Now that 10 o'clock thing that I said, I think there's a shift when you're younger because I watch younger people definitely sleep at different times than old people like me. And it's filled with zinc. And zinc does make you intelligent. People who are super smart have more zinc in their hair. So immunity, ooh, that's big right now. Eat your pumpkin seeds. When you carve your pumpkin, save the seeds and eat them. You do want to lightly low temperature toast them. You can add a little bit of seasoning. So your senses of taste and smell. Well, that's really interesting in this Corona age because that's one of the big things. People lose their sense of taste and smell. And zinc is one of the things they keep commenting that people need to. Actually, in nursing homes, everybody now is on zinc. So why aren't the rest of us? Right. All right. So if you had that mole of pumpkin seeds, this is the slide I forgot to fix this morning. And you divide it amongst all the humans on the planet. Everyone, every 5 seconds had to eat a pumpkin seed. And nobody ever stopped for anything all day, all night. It would take us all doing this all together as one 16 million years. Yeah, you can't stop to get rid of the pumpkin seeds. You have to keep eating. Now, the first 5 are pretty easy, but then the thing is in 5 seconds, I've actually done this with my class, is you don't get a chance to swallow and you're adding another one and it just starts building up and you feel like this pumpkin. What about Mary Poppins? And this is the original Mary Poppins. How could they ever do a different one? And she said a spoonful of sugar makes the medicine go down. All right. What if she had a mole of sugar? Oh my goodness. Well, that would be 342 grams, which is more than a cup of sugar. And if each gram is 4 calories, oh, you can do the math. Take 342 times 4, you're over your 1,200 calories. And a can of soda, that's a can of soda. Nobody drinks a can of soda anymore. Everybody drinks the supersized things. Yeah. So anyway, 87 teaspoons. 87 teaspoons is a mole. All right. This is another one that I love, is the mole of paper clips. We'll do the colorful paper clips. How long would the chain be? Will we make it across the US? Will we make it around the Earth? Will we make it to Pluto? Plutonium was named after Pluto. Actually, it circles our galaxy 20 times. 20 times if you keep all those paper clips. goes around our galaxy. So speaking of our galaxy, what if you had a mole of stars? Well, how many stars equals a mole? Our galaxy has 300 billion stars. Oh my. We would need, to get to a mole of galaxies, a mole of stars, we would need 2 trillion galaxies, each with around 300 billion stars. Holy moly, right? You know, everybody's always so excited. I'm taking astronomy. People say, where do you take it? I'm taking astronomy. Oh, that's so cool. Did you see Mars? You guys all watching Mars is going to be in opposition on October 13th. It means it's the closest it is to our planet and the closest it's been for a long time. That's why this month is so crazy, and we're all going crazy, besides the 2 full moons. Yeah. When people say they're taking chemistry, people go, yeah, I'm taking chemistry. And people almost say, oh, I'm sorry, blessings. But really, you should be going, I am taking chemistry. That's in you. In every atom that then makes up molecules, that then makes up cells, that makes up organs, that makes up you and me and all of us on this amazing planet. The other analogy I gave on that one slideshow was if you had a mole of water. A mole of water is a tablespoon of water. Now, it should be 18 grams of water and a tablespoon's 15, but water does that thing because of the hydrogen bonding where you get that you can actually put more in there. You get that curvature on top. And I have a small hand. Most of you have a big enough hand that that tablespoon of water would fit in your hand. So go do that right now when I get done in a moment. Put water in your hand and just stare at it. That is a mole of water. That is 6.022 times 10 to the 23 molecules of water. That is 2 trillion galaxies of stars in the palm of your hand. If that doesn't make you say, holy moly, I don't know what will. Don't eat a mole of these Milky Ways. Hopefully you're all making a healthy change. If you didn't, you can start now and you would go for the full 30 days. Just be honest about it. Don't give up candy for this month because it's Halloween. You can do it. You can do it. You get past the first 2 weeks. First few days aren't bad, but then, yeah, the cravings happen. All right. And again, we're here. Avogado's law.
That's 6.02 times 10 to the 23rd. Happy mole day to you. How many moles of hydrogen are found in water? Just use the subscript. The number is 2. What is mole? Mole.
I don't know mine.
Coefficient ratio between any 2 formulas in a balanced equation. What is molar mass for a formula? At an atom's atomic masses in grams per 1 mole. How much gas in 1 mole?
NSTP.
That's 22.4.
NSTP.
22.4 liters. Happy mole day to you. Happy mole day to you.
So, let's get that off. Your bonus. And it's going to be on Mole Day. So you might have to figure out when Mole Day is. And hopefully I'll remember to email you, send a reminder. You're going to find your own analogy of mole. or you can send me a mole joke. All right. Many blessings.